Welcome to the third lecture of vectors. Now see, before going through this lecture, what I recommend that you go through lecture 1 and lecture 2, and I hope that all of you who are watching this lecture must have gone through lecture 1 and lecture 2 because those were the fundamentals, how the vector is represented, what is the vector angle, what is the negative of a vector, what is the notation of a vector, which are going to be used and applied in the present lecture. So if you haven't gone through lecture 1 and 2, first I recommend you go through lecture 1 and 2, then come back to lecture 3. And the link of lecture 1 and 2 can be found in the description given below, okay? Now see, in the present lecture of vector, let us see what will be the outline, what will be the roadmap. First of all, we will see what is the meaning of the resultant vector. We will start with the addition of vector and we'll see what is the meaning of physical significance of resultant vector. Then we will see a law, how vectors are added because vectors are added geometrically. So we will see the Polygon law of vector addition. Then we'll see how the Polygon law gives you the zero resultant. And then we'll see important property for zero resultant of vectors of equal magnitude. And finally, we will see how to find the relation among given vectors by the sides of the polygon. So these are the segments of the present lecture. So let's see what is the meaning of resultant vector. Now suppose in your home you have a box, a heavy box, and you want your box, this is the box, and you want that box may be accelerated, you want that box may be accelerated towards north, okay, towards north with an acceleration of 0.5 meter per second squared. This is your goal. Okay, this is your goal, this is your objective, what you want to achieve. And what you do, you call two guys to achieve this objective. And the two guys are applying forces like this. Say he's applying a force F1 and he's applying a force F2, okay? Now, it's a common sense when these two are applying the forces like this, F1 and F2, the box will neither go in the direction of F1 nor in the direction of F2. That's a common sense, right? The box will not go in the direction of F1, nor it will go in the direction of F2. It will go somewhere in between. It will go somewhere in between F1 and F2. And say it is going towards north with an acceleration of 0.5 meter per second square. So this is the physical effect or the physical outcome of the two forces. This is what? The physical effect or the physical outcome of the two forces which are being applied by two men, okay? Now suppose someday one of the men has left and you got only one guy and you want the same physical effect. You want the same physical effect. You want the same physical effect. Same physical effect means what? You want your box to be accelerated towards north at 0.5 meter per second square as it was going before. So it is the same physical effect. Now you got only one guy, and suppose this guy is applying a force F. Okay, this guy is applying a single force F. So this single force F will be called the resultant of the two forces F1 and F2. Again, I repeat, this single force F will be called the resultant of the two forces F1 and F2 because this single force F is giving you the same physical effect, the same outcome as given by the two forces acting together. Getting the point? This single force is giving you the same physical effect as given by the two forces acting together. So this this force, single force F, is called the resultant of two forces F1 and F2. F is the resultant of two forces F1 and F2. And in vector mathematics, in vector notation, we write like this: vector F is vector F1 plus vector F2. Okay. So you can call it the resultant of the two vector or the sum of the two vectors. Either you can say F is the resultant of F1 or F2, or you can say vector F is sum of vectors F1 and F2. So this is the meaning of resultant vector. This is the meaning of resultant vector, which gives you the same physical effect as given by a number of vectors acting together. Okay, like in this case, vector F is the resultant force of the forces F1 and F2. Now we can write what is the resultant vector? A single vector which gives the same physical effect as given by the number of vectors acting together. Okay, which gives the same physical effect as given by the number of vectors acting together. Now suppose you have three vectors, vector A, vector B, and vector C, and you want a single vector, vector R, which gives you the same physical effect as given by the three vectors acting together, then in the language of vector, in vector notation, you can write vector R is the resultant of three vectors, vector A plus vector B plus vector C, or you can say vector R is the sum of the three vectors A, B, and C, and it is written like this. So this is the notation for writing the resultant vector in vector mathematics, the sum of the vectors, okay? So R is the sum of three vectors A, B, and C. Now, if you see displacement, so we all know displacement is a vector quantity. So suppose first you are going from a point O to point A and cover a displacement of A, which has a magnitude of 4 kilometer. Then you go from A to B and cover a displacement B, which has a magnitude of 3 kilometer. Okay. Now you are covering two individual displacements, A and B. A is right 4 kilometer, B is like up 3 kilometer. Now suppose you want the resultant of A and B, right? So basically you need a single vector which will give you the equivalent or combined effect of A and B. So tell me one thing, if you don't want to go O to B via A, suppose you don't want to go like this, O to A to B, but you want to have the same physical effect, the same displacement as this man is having, so you will say, I can go directly from O to B, correct? So this will be the resultant vector in this case. This will be the resultant vector in this case, correct? This is giving you the same effect of displacement as the two vectors A and B are giving together. Got it? So this is the illustration for displacement vector, where you can see a single resultant vector is giving you the combined effect of two displacements. Now, if we see the Polygon law of vector addition, now let's see if you want to add a number of vectors, say 4 vectors, 5 vectors, 6 vectors, okay? And just to illustrate the model prototype, we are taking the displacement vector. Displacement is a vector quantity. So the law by which displacement will be added will be applicable for all vectors, because displacement is a vector quantity. Now suppose you are going from point O to A to B, B to C, C to D, okay? First you are covering a displacement vector A, then you are covering a displacement vector B, then you are covering a displacement vector C, and finally you covered a displacement vector D. This was point B, C, and D, and then you stopped. So basically there are 4 displacement vectors, A, B, C, and D, correct? There are 4 displacement vectors, A, B, C, and D. Now we have to find a single displacement vector, which will be the sum of the 4 displacements. We have seen how we write in the vector notation. We'll write vector R is equal to A plus B plus C plus D. R is the sum of the 4 vectors. So how you are going to make R? How you are going to make R? So let's say if I want to make a single displacement, which will give you the equivalent effect of these four displacement, so you can directly go from O to D, correct? Something like this. So this is giving you the resultant displacement of the four vector. So this is how vectors are added, because as I told you, the law which is made for displacement vector will be applicable for all vectors, because displacement is a vector quantity. And this law is called Polygon law of vector addition. We all know what is a polygon. Polygon is a closed figure by straight lines in the same plane. Closed figure by straight lines in same plane. Okay. So see what says the Polygon law. It is saying that if you want to add a number of vectors, they are represented by the adjacent sides of a polygon taken in the order. Now, what is the meaning of same order? Same order means if you are making the vectors, like suppose you made a vector A, then on the head of A, you will make the tail of B. On the head of B, you will make the tail of C. On the head of C, you will make the tail of D. So you are going in the same order. This is the meaning of same order. Okay. So suppose if you want to add four vectors, say A, B, C, D, represent them by the sides, adjacent sides of the polygon. Represent them by the adjacent sides of a polygon taken in the same order. Taken in the same order. Then if the resultant is R, say R is A plus B plus C plus D, okay? If the resultant is R, then R will be given, the resultant will be given by the closing side of the polygon. Now say this will be the closing side. If you make this side, it will close the polygon. So this is called the closing side. So the resultant will be given by the closing side of the polygon, but see, in which order? Here you are going like this. This is the same order. We are going like this. This is the same order. A, B, C, and D are in the same order. These are the vectors to be added. But the resultant is in the opposite order. Resultant is in the opposite order. So if you are representing a number of vectors to be added by the adjacent sides of the polygon taken in the same order, then the resultant will be given by the closing side of the polygon. The resultant will be given by the closing side of the polygon taken in the opposite order. Okay, taken in the opposite order. Now see, you are going in the same order like this for adding the vectors. The resultant is in opposite order. So this is called the Polygon law of vector addition. This is called the Polygon law of vector addition. You can make this figure. Okay, and then after making the figure, you can write formally what is Polygon law of vector addition. If a number of vectors are represented, both in magnitude and direction by the adjacent sides of the polygon taken in the same order, then the resultant of such vectors is given both in magnitude and direction by the closing side of the polygon taken in the opposite order. And the sides are giving you both the magnitude as well as the direction. We will see its mathematical interpretation very soon, what it means magnitude and direction. Because that side will give you both the magnitude of the vector. Magnitude we have seen means the length of the vector, and direction means the orientation, the angle of the vector. So when a number of vectors are represented by the adjacent sides of the polygon taken in the same order, the resultant will be given by the closing side of the polygon taken in the opposite order. Got it? And by Polygon law, you can add any number of vectors. Any number of vectors. 2, 3, 4, 5, 6, any number of vectors. Now see, when you are adding 4 vectors, 1, 2, 3, 4, how many sided polygon is needed? 5-sided polygon is needed. Because one side is reserved for the resultant. So like we can say, for adding n vectors, n plus 1 sided polygon is needed, correct? Triangle is also a polygon. So triangle law is nothing but the special case of polygon law. Like if you want to add two vectors, how many side of polygon is needed? Three-sided polygon. Three-sided polygon is needed. That is triangle. If you want to add three vectors, you need to have a four-sided polygon. That is quadrilateral. Got it? Triangle is also a special case of polygon. So with the triangle law, how many vectors can be added? Two. So for adding n vectors, we need n plus one sided polygon. Conversely, with n sided polygon, okay, suppose we have a n sided polygon. So how many vectors can be added with n sided polygon? Think and answer. If there is an n-sided polygon, so with n-sided polygon, you can add how many vectors? Right, correct, n minus 1 vectors. N minus 1 vectors can be added. Got it? N minus 1 vectors can be added with the help of sided polygon. Got it? So this polygon law of vector addition. Now say a special case. Suppose we have a number of vectors, and when you are making them, when you are making all the vectors in the same order, the polygon is closed. So this is vector A, this is vector B, vector C, vector D, vector E. So when you made all the vectors, the polygon is closed and they are in the same order. The keyword is they are in the same order. Now we have seen the polygon law. It says that if you want to add a number of vectors, represent them by the adjacent sides of the polygon taken in the same order, then the closing side will give you the resultant vector. Closing side will give you the resultant vector. Now what is happening in this figure? When you are making the vectors in the same order, the polygon got closed. So there is nothing, is no spaces left for the closing side. Okay, so what will be the length of the closing side in this figure? 0. There is no closing side. The closing side has 0 length. So what will be the resultant of such vector? Because the closing side will give you the result, and there is no closing side, so the resultant will be 0 vector. So this is very important property. When a number of vectors are represented by the adjacent sides of the polygon taken in the same order, okay? When the vectors are represented by the adjacent sides of a polygon taken in the same order, they will have 0 resultant. They will have 0 vector as the resultant. The sum will be 0 vector. So whenever you see a number of vectors forming a polygon in the same order, all must be in the same order. You can surely say, just by looking at the figure, you can judge they will be in equilibrium. Equilibrium means vectors are said to be in equilibrium, means they will have 0 resultant. Okay, this is very important property. You can note it down. Whenever the polygon is formed by n number of vectors in the same order, it will give you 0 resultant. Okay. Now same, think and answer which of the following figures gives a 0 resultant vector in this figure. There are 4 options, and you have to tell which figure is giving you the 0 resultant. Suppose there are 3 vectors or 4 vectors, so sum of the vectors will be 0. You can still the video and think for 1 minute and take your option. So right now we have seen when we can have a 0 resultant, when a polygon is formed by the vectors in the same order. Now in this figure, this will not give you the 0 resultant. Vectors are not in the same order. This will not give you the 0 resultant. Vectors are not in the same order. A, D, C, B are in the same order, but A is violating the rule. So this will also not give you the 0 resultant. Here you can see A, B, C, D. This is forming the same order. Can you see? At the head of A, we have a tail of B. At the head of B, we have a tail of C. At the head of C, we have a tail of D. So this is forming the same order. So this will have a 0 resultant. So correct option is option D. Got it? This is the meaning of zero resultant when all the vectors are forming a polygon in the same order. Now see, we know when we have a regular polygon means in a polygon, all sides are equal and all angles are equal. So from the knowledge of basic geometry, each exterior angle in a regular polygon is 2 pi by n radian. N is the number of sides. This is in radian. If you write in degree, it will be 360 degree by n, correct? This is one of the basic geometrical property which we have studied in lower classes. Like equilateral triangle, if you see. So equilateral triangle is a regular polygon, correct? With which how many sides? So it has 3 sides. So if you can see, all the exterior angle will be equal. All 3 angles will be equal, and this will be 2 pi by 3 radian, or 360 degree by 3, that is 120 degrees. In degrees it will be 120, in radian it will be 2 pi by 3. This angle, this angle, this angle, right? If you take a square, it is a regular polygon. Each angle will be 90 degree, correct? So in a regular polygon, each exterior angle is same, that is 2 pi by n radian. Got it? So say if we have n vectors, which can be represented by the adjacent sides of an n-sided regular polygon. Say this is vector A, this is vector B, this is vector C, so on. And this is n-sided regular polygon. So if it is a regular polygon, all the vectors will have the same magnitude, correct? Modulus of vector A, because regular polygon will have all the sides equal, and the length of the side is the magnitude of the vector. So all the vectors will have the same magnitude if they are representing the sides of a regular polygon. And can we say the angle between any two vectors? We have seen how to find the angle. Suppose if you want to find the angle between A and B, and you can see A and B is the head to tail figure, B and C is the head to tail figure. So between A and B, this will be the vector angle. Between B and C, this will be the vector angle. We have seen in head to tail figure, we have to take the supplementary extended angle, line angle. And since it is a regular polygon, we have seen this property right now. Each such angle will be same, 360 degree by n. So this will be 360 degree by n, in degrees 360 degree by n. So if a number of vectors are represented by the sides of a regular polygon, very important property, take care and pay attention, okay? If a number of vectors are represented by the sides of a regular polygon, n-sided regular polygon. So number one, all vectors will have the same magnitude. Convinced? All vectors will have the same magnitude because all sides are equal. Number two, the two consecutive vectors. The angle between any two consecutive pair of vectors will be same and will be 360 degree by n. Angle between any two consecutive vectors will be 2 pi by n radian, or you can say 360 degree by n radian. And can we say if this is the case, then the resultant of such n vectors will be 0? If they are forming a polygon like this in the same order, then the resultant of such vectors will be 0, because right now we have seen if vectors are forming a polygon in the same order, so their sum is a 0 vector, correct? So if you apply the same property in this case, so we have n vectors of equal magnitude, and the angle between any two consecutive is 360 degree by n. So they will be forming the sides of a regular polygon in same order. If these two cases are met, if they have the same magnitude and the angle between any two consecutive vector is 360 degree by n, we will be forming a regular polygon in the same order. So their sum will be 0. Correct? So what we can conclude, there are two properties. You can write these and we'll see the fingertip point, which will be applied in many situations. Whenever we have n vectors of equal magnitude. Number one is this, they must have the equal magnitude. And number two, the consecutive vectors must have an angle of 2 pi by n radian or 360 degree by n. Then their sum or resultant will be a zero vector. Correct? So this is something which we have to keep as a fingertip point. This is something which we have to keep as a fingertip point, which will be applied in many of the situations throughout your 2-year course. Okay? And the logic behind this is this thing. When these two conditions, vectors are having the same magnitude and the angle between consecutive pairs degree by n, they will be forming a polygon in the same order, a closed polygon in the same order. So sum will be 0. Got it? So suppose if I say, what must be the angle between two consecutive vectors? Find angle between two consecutive vectors if resultant of 12 vectors of same magnitude is 0. Okay, now see, there are 12 vectors of same magnitude. See the condition, they have the same magnitude and the resultant is 0. So we have to find what will be the angle between two consecutive vectors. So we have seen if there are n vectors of same magnitude, and if it is giving a 0 resultant, the angle between the consecutive vector will be 360 degree by n. So in this case, n is the number of vectors, 360 degree by 12. So answer will be 30 degree. This is your answer. Got it? So you get questions like this is MCQ. If there are so many like number of vectors which have same magnitude and they are giving you the 0 resultant, so what will be the angle between the consecutive vectors? Okay. So this logic will be applied. We have already seen this property, and I guess you have noted it down. If there are n vectors of equal magnitude, I've written there in the last slide, n vectors of equal magnitude, and the angle between any consecutive one is 2 pi by n radian, or if you are fond with the degree, 360 degree by n, then the resultant will be 0 vector. Got it? See, in the given figure, there are 3 vectors of equal magnitude. What will be the resultant of 3 vectors? Now you can see we have vector A, we have vector B, and we have vector C, and it is given they have the same magnitude, which can be written like this, or it can also be written like this: modulus of vector A is equal to modulus of vector B is equal to modulus of vector C. And you can see all these 3 angles are equal, alpha, alpha, alpha. So what will be the value of alpha? So this whole angle about a point is 360 degree. And 360 degrees divided in 3 equal segments, so angle is 120 degree. So all 3 vectors are subtending same angle with the other one, or the consecutive ones you can say have the same angle 120 degree. So can we see both the properties, equal magnitude property and angle property? Can you see both the properties are met in this condition? All the three have the same magnitude, first property. Number two, how many vectors are there? Three. The angle between any two consecutive the angle between the consecutive vectors is what? Must be 360 degree by n. So in this case, must be 360 degree by 3. That is 120 degree. Correct? This is also meeting. So what will be the resultant? It will have a zero resultant. Applying the same property, so you can say therefore vector A plus vector B plus vector C will be zero vector. Because both the properties are met, all three have the same magnitude, and the angle between any consecutive pair is 120 degree. That is meeting the formula 360 degree by n. So they will have zero resultant. Now say suppose we have an equilateral triangle. Such problems you will see in electrostatics and gravitation. Suppose we have an equilateral triangle, and there are some electric charges at the vertices of the triangle, and there is some charged particle at the centroid, and three forces are acting on the charged particle. Say one force is acting towards this vertex, F1, one force is acting towards this vertex, F2, and one force is acting towards this vertex, say F3. And all forces are having same magnitude. That is, F1 is equal to F2 is equal to F3. Or you can say modulus of F1 is equal to modulus of F2 is equal to modulus of F3. Okay. Now, what will be the resultant force on the particle? You have to tell what will be the resultant force on the particle. Now, see, in such cases, you have to simply apply this property. We know all these three angles will be equal, correct? And this total angle about a point is 360 degree. And there are three segments. It's a triangle. So polygon is, regular polygon is of three sides. So three equal segments will divide the angle. So all angle will be equal, and each angle will be 360 degree by 3. That is 120 degree. Now see, both the conditions are fulfilled. The vectors are of same magnitude. Correct? The vectors are of same magnitude. The angle between any consecutive ones is how much? 360 degree by n. N is the number of vectors. In this case, n is how much? 3. So angle must be 120 degree. This condition is also fulfilled. All three angles are equal. So both the conditions are fulfilled. So what do you think? What will be the resultant of the three vectors? You will say the resultant will be a zero vector, correct? The resultant will be a zero vector. Now say 6 charges are kept at the vertices of a regular hexagon. At the center there are 6 electric field vector. You will see such problem in electric field, but they are simply the application of vector fundamentals. So we have a regular hexagon and 6 equal charges are kept like this. Now electric field is a vector quantity. You need not to think how electric field are formed right now. You simply need to apply the fundamental of vector, nothing else. Okay. So suppose we have like this, and this is the center. One electric field is like this, say E1 vector, vector E2, vector E3, vector E4, vector E5, and vector E6. There are 6 vectors at the center of a regular hexagon, and they all have same magnitude. So we can write magnitude equal. You remember how we write the magnitude? You need not to put the vector sign. Okay. And we have to find the resultant of the vector. What will be the resultant of 6 vectors? Okay, can we see all these angles will also be equal? Correct? All these 6 angles will be equal. If this is alpha, this will be alpha, this will be alpha, 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 alpha. And what will be alpha? 360 degree divided by 6. Correct? Angle at a point is 360 degree and it is equally divided in 6 segments. It will be 360 degree by 6. Number of vectors is also 6. So this is of this form. So again, you can see both the conditions are fulfilled. There are 6 vectors of equal magnitude. 6 vectors of equal magnitude. The angle between any two consecutive is 360 degree by 6. So the resultant will be 0 vector, following the same property which we have studied. The resultant of all the 6 vectors will be a null vector or a 0 vector, correct? So you can apply this property in number of cases, especially in the chapter of gravitation and electromagnetism. Now see the next application. Finding the relation among the given vectors in a polygon. This is also very important. Suppose you are given a number of vectors like this. And they're giving something like this arrow, this arrow, this is the arrow, and this is the arrow. This is A, B, C, D. And you have to relate them. Relation means finding some equation among the vectors. Okay? You have to find some equation among the vectors. Now, simply you have to apply one property which we have learned in the Polygon law. If you are traveling a polygon, in same order, and you're coming back to the same point, then the sum of the vector will be the 0 vector. We have seen this property, correct? If you travel a polygon in the same order, and coming back to the starting point, then the sum of all the vectors will be 0 vector. Now see one thing, suppose this is vector A. If you travel vector A in the direction of vector A, suppose we are traveling in like the direction of A, you will take plus A. If you are traveling opposite to the direction of A, you will take it minus A. In forming the equation, you will follow this rule. If you're traveling some vector in the direction of the vector, take it plus. If you're traveling opposite to the direction of vector, take it minus. Okay, you can write these 2 points. Now see in this case, say I am starting from point O, I'm giving it a name O. It is not necessary to give it a name, just for illustrating, I'm giving it a name O. And I'm going anti-clockwise and coming back to O. So first of all, I will travel A, and I'm traveling A in the direction of A. So first vector is A. Then I'm traveling B. And you can see vector B has an arrow downward. So I'm traveling B opposite to the direction of B. So I'll take minus B. Then I'm traveling C in the direction of C. I will take plus C. Then I'm traveling D opposite to the direction of D. So I'll take minus D. And I came back to the same point. So the sum will be 0. So I will have the relation A minus B plus C minus D will be a 0 vector. This can also be written like A plus C, and B and D can be transported on the RHS, B plus D. It depends on the MCQ option, how the option are given. This is the fundamental equation, or you can write it in many forms. Okay, so this is the fundamental, how to obtain the relation among different vectors in a polygon. Start from any one point, go in some particular order, either clockwise or anti-clockwise, whatever you like. If you're traveling the vector in the direction of vector, take plus sign. If you're traveling it opposite to the direction of vector, take minus sign, and the resultant will be a 0 vector. Let's see 1 or 2 more illustrations. Suppose we have something like this. Okay, we have a vectors like this, say P, Q, R, S, T. Okay, and I have to obtain a relation among the given vectors. So say I'm starting from this point and going again anti-clockwise. So first of all, I will travel P in the direction of P plus P. Then I will travel Q opposite to the direction of Q minus Q. I will travel R in the direction of R plus R. I will travel S in the direction of S plus S. I will travel T opposite to the direction of T minus T will be a zero vector. This will be the relation. Got it? This will be the relation among the vectors. Okay? If you see one more illustration, suppose we have something like this. A, B, C, D, E. And say I'm starting from this point and I'm going now clockwise. You can go either way. It will not affect your answer. So I'm starting from this point and I'm going clockwise. So I'm traveling E in the direction of E plus C. I'm traveling D in the direction of D plus D. I'm traveling C in the direction of C plus C. I'm traveling B in the direction of B plus B. I'm traveling A in the direction of A plus A will be equal to, I came back to the same original point, sum will be 0. And this is, you can see also, all the vectors are forming a polygon in the same order. Can you see? The vectors are forming a polygon in the same order, so their resultant must be 0, which is also coming by applying this relation equation. Okay? So this is how we can find the relation among different vectors represented by the sides of the polygon. Now see, when we talk about the equilibrium of the particle, whenever the particle is in equilibrium, it means the net force on it. Net means the resultant force. Suppose it is acted upon by 5 forces. So the sum or the resultant of 5 forces will be 0. The net force means the sum or the resultant of all the individual forces. So whenever the particle is in equilibrium, the net force on the particle is 0. Net means sum or resultant. Okay? And the equilibrium are of two types. One is static, one is dynamic. When the particle is at rest, it is called static equilibrium. And when the particle is in uniform motion, it is called dynamic equilibrium. Now, what is the meaning of uniform motion? Motion with constant velocity. Either you can say motion with constant velocity, or you can say motion in a straight line with constant speed. When you are saying constant velocity, you need not to say straight line, because velocity, if velocity is constant, it means a straight line. But when you are saying constant speed, you have to mention a straight line. So whenever there is a motion with constant velocity or motion with constant speed in a straight line, it's a uniform motion, and the particle will be in dynamic equilibrium. In both the cases, the sum of the forces will be 0. Whether the particle is in static equilibrium or it is in dynamic equilibrium, the sum of the forces will be 0, correct? Now see, a car is moving with uniform velocity and is acted by 3 forces. Which of the following figures can best represent the forces? So suppose you are given 3 options. There are 3 forces and we are given 3 options, which are the representation of the forces, say like this: vector F1, F2, F3. Option B, F1, F2, F3, and option C, F1, F2, F3. Got it? You have to tell me which option is correct. So it is being told that your car is moving with a uniform velocity. Now, uniform velocity means it is in dynamic equilibrium, correct? So the net force on it must be equal to 0. We have seen right now. something is in equilibrium, whether static or dynamic, the net force will be 0. So if it is acted by three forces, so the resultant of the three forces must come to be what? A 0 vector. So basically the polygon figure must fulfill this condition. The three forces must be represented by the three sides of a polygon so that their resultant will be 0. And in today's lecture, we have seen when the vectors give a 0 resultant, they will be forming a polygon in the same order. They form a polygon in the same order. In this case, F1 and F2 are in same order but not F3, so their resultant can never be 0. In this case, F3 and F2 are in same order but not F1, so their resultant can never be 0. In this case, you can see F1 head has a tail of F2, head of F2 is at the tail of F3. So they are in the same order, so their sum will be 0. So this is representing the sum of the three forces will be 0. So answer will be option C. Got it? So when in MCQs, in competitive MCQs, we have questions like this. A particle is in static equilibrium or moving with constant velocity, acted by three forces or four forces or five forces. So which of the figure will give the representation of the forces? So this fundamental will be applicable. If it is in equilibrium, the net force will be 0. So the forces will be forming a polygon in the same order. Forces will be forming a polygon in the same order. Okay. Now that's the end of lecture 3. Now let's see the roadmap of the next lecture, the subsequent lecture, that is your lecture 4, in which we will cover first some of the geometric properties, because vectors are added geometrically. Right now, today you have seen the vectors addition is geometric addition. They are not added mathematically. They are added by geometric figures. So you must be very much clear about some of the geometric properties, so you can easily solve the vector problems. Then we will see special case of Polygon law, the triangle law of vector addition. Triangle is also a polygon, three-sided polygon. So triangle law is nothing but a special case of Polygon law by which we can add two vectors. So we will see triangle law and derive some equations for it. And then we'll do some